refraction through a prism. You know about prism. You studied in the 10th standard and you saw the prism in your school labs also. So what is meant by prism, or what do you know about this prism? A prism is a wedge-shaped portion of a transparent refracting medium bounded by two plane faces inclined to each other at a certain angle. So two plane faces, when it is inclined at a certain angle, we get prism. So generally we are used the glass type prisms which refract the light. In another one way we can say about prism, it is a transparent optical material with flat polished surfaces that refract light. And this is the principal section of the prism, and it is noted as A, B, C. Here we want to study some important terms, that is the incident ray, refracted ray, emergent ray and angle of deviation. Here a ray of light incident on the refracting face AB, then it refracted inside the prism and it emerges out from the next face AC. So the ray is noted as P, Q, R, S. This is the normal for the refracting face AB and this is the normal for the face AC. So incident ray is the ray which is incident on the prism. That is the incident ray. It is noted as PQ. Then refracted ray means the ray which is refracted inside the prism. That is noted as QR. And the emergent ray means the ray which is emerged out of the prism. It is noted as RS. So when the ray of light enters from air medium to the glass medium, that is rarer medium to the denser medium, it bends towards the normal. And when it enters from, or when it passes from denser medium to rarer medium, it bends away from the normal. So this I is the angle of incidence and this E is the angle of emergence. And R1 and R2 are the refracted angle. This is the first refracted angle and this is the second refracted angle. So these two are the refracted angle. Why? Because here when the ray of light passes from right side to the left side, this is the refracted angle. And this is the angle of incidence and this becomes the angle of emergence. Okay. Then here this angle A is the angle of prism. So angle of prism means the angle included between the two refracting faces is called the angle of the prism. Then this angle is the angle of deviation. Here, due to this peculiar shape of the prism, at this point, this incident ray deviated from its original path. Then it emerged from the prism. So the angle at which the incident ray deviated from its original path, that angle is known as the angle of deviation. So this is about the prism and how the ray refracted and emerged out of the prism, or how the refraction of light takes place inside the prism. Now let us derive the expression for the angle of deviation, then refractive index of the material of the prism, etc. So for that, first you consider some triangles and quadrilaterals, etc. So first here we are going to consider the quadrilateral AQNR. So here the quadrilateral AQNR. Okay, quadrilateral AQNR. So we can write here, that is the quadrilateral AQNR. So first you consider the quadrilateral AQNR. So there you know that in any quadrilateral the sum of the opposite angles is equal to 180 degree. So here this angle A and angle QNR, these two angles are opposite angles, so its sum is equal to 180 degree. So we can write here angle A plus angle QNR equal to 180 degree. Equation number 1. Then next opposite angles, that is the angle Q and angle R. So these two angles are 90 degree. This angle Q equal to 90 degree and angle R equal to 90 degree, and sum of all the angles of a quadrilateral is equal to 360 degree. So we can write here, that is angle Q equal to angle R equal to 90 degree. Then we can consider the triangle, that is the QNR, this triangle. Okay, QNR, triangle QNR. So in this triangle, angle R1 plus angle R2 plus angle QNR equal to 180 degree. So we can write here, that is R1, angle R1 plus R2 plus angle QNR equal to 180 degree. So we get these two equations from the ray diagram. Then you compare this equation 1 and equation 2. So what is from this equation 1? How can you write here? That is angle A equal to 180 minus angle QNR. So once again we can write one more step, angle A equal to 180 minus angle QNR. Then we can note it as equation number 3. And so this equation 1 implies this equation. Then here, then equation 2 implies R1 plus R2 equal to 180 minus angle QNR. That is noted as equation number 4. So how can you write this equation number 4? That is R1 plus R2 equal to, what is 180 minus angle QNR? That is equal to angle A. Okay, so we can write A. That is noted as equation number 5. Clear? Then again you consider the triangle QMR. From the ray diagram, again you consider the triangle QMR. So here from the triangle QMR, okay, here this is the triangle, that is QMR. So here this delta is the exterior angle. Okay, delta is the exterior angle. So you know that exterior angle is equal to sum of the interior angle. So here QMR, this is the interior angle. Okay, this is the interior angle. So this delta is equal to sum of these two interior angles. So what is this, what is the value of this interior angle? This total angle is I. Okay, this total angle is I, because these two angles are opposite angles. So this total angle, okay, that is the I. So what is this one? that is I minus this R1. So we can write here I minus R1. Similarly, this total angle is this emergent angle. Okay, E. This total angle is emergent angle, this E. So what is this angle? So we can write E minus this R2. Clear? So we can write delta, exterior angle delta equal to I minus R1 plus E minus R2. Okay. So from the triangle QMR, we can write delta, deviation delta equal to I minus R1 plus E minus R2. So from this again we can write delta equal to I minus R1 plus E minus R2, that is equal to I plus E minus of R1 plus R2. Clear? So we can write here delta equal to I plus E. What is R1 plus R2 from the fifth equation, that is A. So I plus E minus A. This is the relation between, this noted as equation number 6. So delta equal to I plus E minus A. So this is the relation between angle of deviation, angle of incidence and angle of emergence. So angle of deviation delta equal to I plus E minus A. Clear? There are some factors on which the angle of deviation depends. First one, the angle of incidence, then number 2, the material of the prism, then the third, wavelength of the light used, and the fourth, angle of the prism. So in the case of the material of the prism which represents the refractive index of the prism. So angle of deviation increases with the increase in the refractive index of the prism. In the case of the wavelength, angle of deviation decreases with the increase in the wavelength. So here, when the white light enters the prism, then what happens here? It splits up into 7 colors, and you know that red light has the longer wavelength than the violet light. So when it deviated from its original path, the red light deviates the least than the violet light. Okay. So we can say that the angle of deviation decreases with the increase in the wavelength. Then it depends on the angle of the prism. Angle of the prism, that means angle of deviation increases with the angle of the prism. Then we can see the variation of angle of deviation with the angle of incidence. So when you see the variation of angle of deviation and angle of incidence experimentally, we can draw a graph like this. So this represents that we can draw the angle of incidence on the x-axis and angle of deviation on the y-axis. So this represents that when angle of incidence increases, angle of deviation first decreases and reaches a minimum value. Then when the angle of incidence increases, angle of deviation again increases. So this is the relation between angle of incidence and angle of deviation. Once again, when angle of incidence increases, angle of deviation decreases and reaches a minimum value. Then when the angle of incidence increases, angle of deviation again increases. The minimum value of angle of deviation is known as the angle of minimum deviation. It is represented by delta M. So in the figure you can observe that for a value of angle of deviation, there should be two values of angle of incidence. That is the angle of incidence I, and this is the angle of emergence E. So this delta remains the same when this I and E are interchanged. It means that the path of the ray can be traced back. In the figure you can see that when the ray of light passes from left to right, this is the angle of incidence and this is the angle of emergence and this is the angle of deviation. When the ray of light traced back, that is from the right to left, this becomes that means angle of emergence becomes the angle of incidence and the angle of incidence becomes the angle of emergence, but delta remains the same. So delta remains the same when I and E are interchanged. It means that the path of the ray can be traced back, resulting the same angle of deviation. Clear? Then at this minimum angle, that is the at delta m, at this minimum angle of deviation, this angle of incidence is equal to angle of emergence. So in this case, we can say that in the figure, the refracted ray becomes parallel to the base of the prism. That is at the angle of minimum deviation, when delta becomes delta m, the refracted ray becomes parallel to the base of the prism. That time the angle of incidence is equal to angle of emergence. So this is very important point. So at I equal to E, then delta equal to delta m, then the refracted ray becomes parallel to the base of the prism. Clear? Then from the above equation, that is the, what is the angle of deviation formula? That is delta equal to I plus E minus A. This is the angle of deviation. So in this case, when this delta becomes, that is minimum deviation, we can note it as dm or delta m. Okay, here we can note it as dm, or we can note it as delta m. So when delta becomes minimum deviation, that is the dm, or we can write delta m. Okay, both are correct. We can note it as delta m. So when delta becomes delta m, minimum deviation, you can write I equal to what? I equal to E. So in this case, what is this R1 and R2? That is the refracted angle. So here R1 is equal to R2. When I equal to E, then R1 is equal to R2. So we can write here R1 equal to R2. Okay, R1 equal to R2. Then what happens here? This equation. So here in the above equation, that is the R1 plus, you know that one equation we written in the first case, that is R1 plus R2 equal to A. So in this equation, we can write R1 equal to R2. We get angle of refraction, that is 2R equal to A. Therefore, angle of refraction R equal to A by 2. So in the case of angle of minimal deviation, angle of refraction R equal to A by 2. Clear? Then we can find out the angle of minimum deviation. So in this equation, we can write delta equal to delta m, then I equal to E. So we can write 2I. Okay, 2I minus A. Therefore, what is from this equation? What is I? I equal to A plus delta m divided by 2. So this is the angle of incidence. So in the case of angle of minimum deviation, angle of refraction R equal to A by 2 and angle of incidence I equal to A plus delta m by 2. Then using the Snell's law of refraction, we can write the equation for the refractive index of the prism. So you know that what is the, that means using the Snell's law of refraction, what is the refractive index of the material of the prism? That is refractive index of the second medium. Second medium means it is the glass medium with respect to the first medium, that is the air medium, that is N21 equal to N2 by N1, that is equal to sin I by sin R. Clear? Sin I by sin R. So here, that is once again we can write refractive index of the second medium with respect to the first medium, that is N21 equal to N2 by N1. Then we can substitute I and R. So what is I? That is sin A plus delta m by 2. Then divided by sin A by 2. Okay. So this is the refractive index of the prism. That is refractive index of the prism N21. That is here N1 equal to air medium. So we can note it as N1 equal to 1 and N2 equal to N. So finally we can write refractive index of the material of the prism N equal to sine A plus, okay, sine A plus delta m by 2 divided by sine A by 2. So this is the equation for the refractive index of the material of the prism. That is n equal to sine A plus delta m by 2 divided by sine A by 2. Then we can write on case if the for the small angle, that means if the angles are very small in the case of the thin prism, then this delta m is very small, then the angle of incidence and the angle of refraction is also small. That means we are assuming that if the prism is a thin prism, then the angles are very small. So in that case we can write the last equation, that is n equal to sine of A plus delta m by 2 divided by sine A by 2. We can write like this, that is n equal to, the angles are very small, then sine theta is approximately equal to theta. So we can write A plus delta m by 2 divided by A by 2. Then we can cancel this 2 and 2, then we get n equal to A plus delta m divided by A. So from this equation we can write the angle of minimum deviation, that is n equal to 1 plus delta m by A. Okay, so here again we can write delta m by A equal to n minus 1. Clear? Therefore n equal to what? That is, so we can write the delta m. Okay, so delta m equal to n minus 1 into A. So this is the equation for the angle of minimum deviation. Delta m equal to n minus 1 into A. So this deviation, this is the deviation produced by a small angled prism, and it does not depends on the angle of incidence. Okay, so this angle of minimum deviation depends on angle of the prism. It does not depend on the angle of the incidence. It depends on the angle of the prism and refractive index of the material. Clear?